Hi, welcome back to SQL Server 2016 Administration. This is the Execution Plans and Query Stores section, and in this video we're looking at reading execution plans. In this section we want to talk in a little more detail how we can read a visual execution plan. We'll talk about the different operators and details, and we'll see how we can use this information in the plan to actually help us tune queries or examine what's going on with our queries. Now, many people are familiar with how they get execution plans in Management Studio, but if you're not, don't worry, we'll show you how to do that. The previous video touched on this briefly, but here we'll go into a little more detail. There is some debate in the world of how we read query plans. Some people say read left to right, and some read right to left. Either way works, but you need to understand what exactly you're looking at. If you read from left to right, what you're seeing is the flow of control, and I'll show you that in a query plan. But if we go from right to left, what we're actually doing is the flow of data, because the data will start on the right side, coming out of our various tables and variables, flow into the various operators to return at the very last operator on the left side. Now, graphical plans are the easiest to read, but they do hide details, so you want to be careful about that. In an execution plan, there's a number of different operators, and each type of operator represents a different operation that's actually processing your data. The operator is also a percentage of work being done with a cost, but it's an abstract concept, so you want to be careful in using that too much detail or putting too much credence into what that actually means. Understand the cost is relative for that plan. It doesn't necessarily relate to any other plan or any other execution of that particular query. Now, in the plan, there are details that show logical operators and physical ones. The logical operator is what the execution plan contains and should be run. The physical one shows what actually happens. They almost always are the same, but they could be different. And there are many types of operations. Each one is for some specific operation needed to assemble data. You can get more details in books online of the different operators and understanding how you might use those to tune your queries. Now, plans have lots of details in them. The XML version kind of shows everything. If you watched the previous video, you saw how complex the XML is. You need to understand that working with execution plans takes a little bit of practice. There's a bit of an art to trying to determine which operations and which parts of the plan are causing problems and which ones are just natural work. Costs and percentages are useful, but use them as just a rough guide. Don't get too caught up in them. And remember, you always have to spend 100% fulfilling a query, so something is always going to take some amount of time. Lastly, I want you to know that SQL Server Management Studio version 17 and greater has the ability to compare plans, and we'll see how this works. Let's take a demo and take a look at how we can get some more details from our execution plans. Here I am back in Management Studio, and I'm working against AdventureWorks. I've got a little stored procedure here that's going to query two tables and join them together with a parameter. So let's run this, and then let's get some details. Now, I've got include actual execution plan selected here, so we'll get the actual plan. Let's run both of these queries together because I want to show you something we might learn from the plan. Now, you see I get two result sets. This one has 1,400 some rows. This one has 120,000 some rows. Now, in the execution plan, there's a few things we want to look at. First, I have this query cost. Now, this is relative to the batch. And so, in this case, I ran two different queries in the same batch. So here's plan for the first query with the date of 2011. And here's the plan for the second query. Plans look very similar, and as a matter of fact, they both took about half the effort in terms of Management Studio here. You'll notice my query is listed, and then I have this missing index item. This is a new addition to SQL Server in recent versions that attempts to let you know when the optimizer thinks a missing index might help your query. Be careful of using this too judiciously. This says create an index with some name on the order date and include the sales order ID, which will satisfy this query. Keep in mind that all indexes cause load in terms of updates, inserts, and deletes. And so if this query doesn't help any other, if this index doesn't help any other query, you might not want to create it. Now, the thing I wanted to show you here is that the cost is about the same here. Both of these do a cluster index scan and another column store index scan and a hash match and a sort. There's a percentage by each one of these, and you'll notice that the hash match takes about half the cost of the query because there's a lot of work to join that information together. In this case, you'll notice that there are some little warnings here. In this case, the operator just spilled a temp DB, and you'll see the warning listed here. If I sort had to write these pages with granted memory, and the memory is the interesting thing here. If I hover over this select query on this operator, you'll see I had a memory grant of 3601. Now, don't forget, this returned just over 1,400 rows, so the estimate was fairly close here. So this memory grant was probably appropriate. Let's look at the other one. If I come to this one and go in, this estimate was the same, the memory grant's the same, but the actual number of rows returned was 120,000. this is not really a sufficient amount of memory here. And this is indicative of a potential issue with this query plan. Because the query plans are reused, in this case, I use a stored procedure. An estimated plan is created by the query optimizer. That got run with this parameter, which is much different than this parameter. So there's a potential issue here. There are various ways you might fix this. You might recompile occasionally. You might do something else here that would help create an index. But keep in mind, the query plan is what lets me know that potentially I've got an issue here between these two queries. Let's look at another case. Here I've got another stored procedure. It's a fairly simple one where I'm going to query a table with a parameter. In this case, if I run with this parameter, my execution plan is an index scan, and we'll notice here that this 400 rows are returned. Here the actual number, and the estimate was 434. So that's pretty close. That's a good number. Now let's look at this for Phoenix. When I run this, you'll see that things are a lot different. And in fact, this is indicative of another problem. We read a lot of rows here because we scanned. The actual number of rows was 5, but the estimate was again 434. That's indicative of a potential issue here with our query plan, that there's a plan that works well for London but not well for Phoenix. If I run this more often, that's potentially an issue because I'm doing more work than I need to do. And again, I've got a potential missing index that could help me here. Thing to keep in mind when I run this, I only get those 5 rows there. And so ideally I want some way that works in a quick scan to get this information. You'll notice here when I run the query by itself, it says it's recompiled for this particular parameter. It estimates only 1.5 rows returned and 5. Those are fairly close. That's indicative of I've got some sort of parameter sniffing issue here. So in this last demo, what I've done is I've created a new table here. In this case, I've inserted some rows into the new table from an existing table. And then I go ahead and insert a bunch more. And I did this because there's an additional scan here of some data. I turned off statistics, and then I added a lot more rows. Then I created this stored procedure that will actually run similar to the last one. Let's execute that and get the plan. You'll see I get 10 rows back, and when I look at this, I'm getting a table scan because there's no indexes in here. And so that's potentially problematic. The other things that I want to show you, we estimated 2 and we got 10, that's not too bad. This item though is potentially an issue here. Anytime I see an implicit conversion, I'm converting data types, which are potentially expensive conversions and potentially performance issues. Query plan allows me to figure out what's going on there. If I run this again for London, which has many, many more rows, I'll get a similar issue. 434 rows, which is closer to the estimate, but I have that convert implicit again. Let's try to fix some things. Now I can create an index here. Create that index, there we are. And now when I run this plan, what I'll actually get is a better plan. I get an index seek that has very close to what I expect, 10 rows with 2 estimated. And I still have that convert implicit there. If I run this plan, what will I see? Well, I'll still see that index seek, and things look worse though. Just like in the first demo, 434 actual rows, but I'm estimating 2. I've got a statistics issue here, right? These 2 values are substantially different, and that leads me to another issue. But apart from that, let's also fix our procedure. So in this case, I'll change this to an nvarchar. This way, there still will be an implicit conversion from here to here, but it won't take place with every row. So now when I run this query, what I'll see is just an index seek. And when I look at this, 10 rows, I estimated 2 again. Very good. And I don't have that implicit conversion anymore. At the very bottom here, you'll see that I'm just going to a scalar operator for my predicate. So I fixed potentially one issue there in a large table. I still have this London issue though, where potentially I have the wrong number of rows there. I could update statistics and fix that. The last thing I wanted to show you is, in an earlier video we showed you how to save a plan here. Let's save this plan as the packed plan. We'll overwrite that one. Now what I'm going to do is I'm going to drop this index, and then what I want to do is rerun the query. So let's drop this index. We'll rerun the query. And we'll see here we get a table scan. Not the best plan, but how does that compare with the last one? If I right click here, you'll notice I have a compare show plan. I can pick that plan that I just saved. And Management Studio will give me a comparison. And so then I can see that I had a table scan up here and an index seek down here. If I look at the properties, I can see in a side-by-side window of how some of the different items compared here. In this case, the subquery cost is much less here than it is over here. any other differences that were there, I could actually look through. These are fairly simple plans, so there isn't a lot of difference there, but more complex plans, I have the ability to see what might be different in these plans. If you've got Management Studio version 17, which is free, you have this compare plan. The last thing I wanted to show you is that if I click on this table scan operator, you'll notice that if I hover, I get some information. If I move around, it's gone. I do have the ability to get the properties there and see more information than appears in that actual pop-up tooltip here. So I can see, what's actually going on by expanding all these out. I can see the different information that I want to get about this plan. I can look at it in more detail, and this allows me to then debug and understand how the work is being done by SQL Server to satisfy my query. In our next video, we'll take a look at the introduction to the Query Store.